Alright, in this video we'll learn to graph some common trig functions such as sine function and cosine function and tan function. Also, we'll look at their inverses. So the inverse of sine is cosec, and the inverse of cosine is sec, and the inverse of tan is cot. Okay. Well, first of all, you need to know that the natural period for sine and cos is 2 pi, or 360. So are the periods of cosec and sec. That's 2 pi, or 360 degrees. The natural period of tan is pi. All right? So I'm going to draw the sine function first. So this is y equals to sine of x. Okay, so this is y here, this is x here, and angle. As angle increases, the sign fluctuates between -1 and 1. So it oscillates up, down, and up. And that is 2 pi. So that's what it means by the period is 2 pi. It continues on forever, so you have infinitely many oscillations, okay? So when you have to draw a sine function, you have to draw this shape, infinitely many of them, unless they give you some sort of domain. They confine the domain for you. So if x is between 0 and 2 pi, that's all you have to draw, okay? I mean, up to just here, okay? So not this part, all right? Now, let's draw cosine function. The cosine function is very similar to the sine function. So this is x, this is y again. Well, it starts from 1, okay, and it oscillates down and then up. Okay, so that's one oscillation for cosine, and this shape repeats, so it will just will be continuing like this. All right, and these are the extensions of the cosine, and so the sine, it extends, so it just continues on forever like this. Okay, so I just drew the shape of sine function and cosine function from 0 to 2 pi. All right, and now the tan function, the tangent function, looks like this. So it starts from 0, shoots up to infinity, and that's where you have your asymptote. Okay, and this is pi on 2, that's 90. And then it starts from negative infinity, and then comes back to 0. Okay, and that's one period. Okay, so that's pi. All right, and then it continues. It continues on as if it's starting again from 0 right here. Okay, so it goes up again, shoots up to infinity, and then there's asymptote, and then it's this part again repeated. Okay, like this, and because it's 2 cycles, so that's one. Oops, yeah, there was a bit of interruption on my computer. So for tan function, you see, that's one period up to pi, so that's why the period for tan is pi. From there, it continues on as if it's starting again from the origin here. Okay, so it shoots up to infinity. There's asymptote, and there will be this. It starts from negative infinity back to 0, and that's where 2 pi is, because that's one period is pi, and that's 2 periods, so that's 2 pi over here. Okay. And the middle point is the asymptote. There's another asymptote, and that value is halfway between pi and 2 pi. That's 3 pi on 2. Now we're going to investigate the inverse trigonometric functions. So that's cosec, sec, and cot. So in order to understand how to draw these graphs, you need to understand those basic concepts. So 1 divided by, for example, a very small negative number is negative infinity. You just need to understand this one. Also, 1 divided by a very small positive number, I'm going to call that positive 0, is positive infinity. And 1 divided by positive infinity is 0, but slightly positive. And 1 divided by negative infinity is equal to negative 0, which means a very small negative number. Okay, I'm going to check that for you using my calculator right here. So, firstly, let's have a look at this one. 1 divided by a very small negative number. So, say 0.000000000000001, and you press enter. You get a negative 1 times 10 to the power of 13. So that's a very large negative number. And likewise, if I just go for this one, 1 divided by a very small number, 1 divided by, very large number, infinity. Of course, I can't actually plug infinity in here, but I'm going to plug this number in. And that gives me a very small positive number. Okay, so I'm going to call that, I'm going to write that as positive 0. Positive 0 means positive small number. Okay, so using these concepts, so I'm going to just erase off the cosine and the tan function. I'm just going to look at the cosec function first. Okay, so let's give it a go. Oh, that's a bad line. By the way, sine function oscillates from 1 to negative 1, okay? All right, so for sine function, of course, this value here is pi, and that's where 90 is, pi on 2. We know that sine pi on 2, sine 90 is 1. That's why it's 1 right here. This value here is 3 pi over 2. That's 270. Okay, so that's 90, 180, 270, and 360. You see, cosec of x is nothing more than just the inverse of sine. So that's inverse of sine of x, which means it's the inverse of y, because y is sine of x. So take a look at this. So it is, so as the angle tends to 0 from the positive side, you can see that it's the y value for the sine function is positive 0, which means very small positive number. You can see that that's a very small positive number. So when you plug the very small positive number into here, and that's what's going to be the cosec function, okay? So when you plug in a very small positive number, or positive 0, so 1 divided by positive 0 is infinity. So the cosec function is infinity. It starts off with infinity, okay? And when it comes to the angle pi over 2, right over here, the sine function is 1. So when you plug in 1 here, what's 1 over 1? That's 1. So it actually goes through this value 1 right here, okay? All right, and then it goes down to 0 again as the angle tends toward pi. And you can see that when it reaches pi, it's a positive 0. So what's 1 divided by positive 0? That's also infinity. So it shoots up to infinity. Okay? Now, but when it reaches pi, then the sine function is 0. But you can't have 1 divided by 0. Okay? You can't have 1 divided by very small numbers like this and this. But that's undefined. So that's where we have an asymptote, okay? So it's a line that the function never touches, okay? And guess what? This is pi. That's where pi is, okay? So when sine is pi, and when x is pi, sine is 0, and because cosec is 1 over sine, we have 1 over 0, and that's undefined, so therefore we have an asymptote, okay? When you look at this point here, that's negative 1. When the angle is 3 pi on 2, that's negative 1. So at angle of 3 pi on 2, we have negative 1. So what's 1 divided by negative 1? That's going to be negative 1. So it goes through that point. That's negative 1. But you look at this point here, very close to pi, to the right-hand side of pi, you have negative 0, which means negative, very small negative number. So that means it's at negative infinity, which is this one right here. So it starts with negative infinity, and then it reaches negative 1. And this point corresponds to that point there. And when you go up to 0 again, okay, so that's getting very close to, when it comes to very small negative number, that's negative 0, it goes to negative infinity again, okay, so it goes down again, okay, and at 2 pi you have another asymptote, okay, so this is the graph of the cosec function. All right, so it's very simple. Okay, if you just understand these, then you can plot this using this graph. Okay, of course you have to first understand why the sine graph looks like this. If you don't understand this one, I can do another video on it. Now, likewise, so let's do a new slide. Actually, I'm gonna just erase it off. All right. So how do we draw the sec function? Okay, let's have a look. So you see the sine function started from 0 and it went like this, and that's 2 pi. But cosine function starts from 1 and then goes like this, and that's 2 pi. You see? And that value here is pi on 2, and if we actually translate the sine function to the left by just pi on 2 much, so that point goes over there, this point goes over there, this one goes over here, and this one goes over there, and this one goes over there, then what we get is this. And because there is this missing part here as well, wouldn't that also go this way and thus create that, you see? But doesn't this part look like the cosine function? So therefore, we saw from the previous case that the cosec function, this is graph of sine, this one is cosine, cos of x, this one is cosec, and that looked like this. Okay, and this is where 2 pi was, and this is of course pi, and this is where pi on 2 is. So therefore, if you just as you can get cosine function by translating the sine of x to the left by pi on 2 by 90 degrees, you can obtain the sec function by translating the cosec function by 90 degrees to the left. So let me just draw that out for you. So I'm going to draw it a little nicely for you. You do that. That's x-axis, y-axis. that point goes over there. Okay, so I'm going to draw all the arrows. Goes over there. The asymptote also moves by pi on 2, so that point goes over there. Okay, so the asymptote is where pi over 2 is, and you just get that's 1 and goes up to infinity. And this 2 pi goes to where 3 pi over 2 is. So this is 3 pi over 2, and we have that. And then there was this undrawn portion right here. Okay, that part arrives at 2 pi. So at 2 pi, so that's 2 pi, we have that. Okay, and of course it continues on like this, shoots back up to infinity again. So this and this and this, that's within 2 pi. Okay, and that's one period of the sec function. All right. Okay, so how do we also draw the cot function? This is tan function, as I showed you before. This is y equals to tan of x. This is x, and I actually drew 2 periods. Okay, so that's 1 period. Okay, that's 1 period, pi, and that's the second period. Okay, so that's 2 pi. All right, so it shoots up to infinity, and then asymptote, and then from negative infinity to 0 at pi, and then up to infinity again, and then asymptote, and then negative infinity to 0 again. So, what cot function is nothing more than just 1 over tan. So, let's draw this. So just using these tricks right here, so you can see that that's positive 0. Okay, so I'm going to actually so that's positive 0. I'm going to do that in green, and that's basically this one, right? And I'm going to choose yellow color for this one. That's infinity. That's basically that's 1 over positive infinity, so that's this one right here. Okay, so for this part we have infinity, so definitely it's going to be starting from the infinity. Okay, and when it comes to this point, which is pi and 2, but there's no more asymptote. It's negative, positive infinity right here, so 1 over positive infinity is 0, so that's why it is going to hit positive 0. It's very small. Eventually it hits 0. Okay. But even though this one never hits the asymptote right here, this graph does hit this point pi on 2, because when it goes to infinity, it'll be 0 right here. And it starts with negative infinity right here to the right of the pi on 2. So 1 divided by pi on 2, I'm going to do that in red. So that part is red, circled red. And 1 divided by negative infinity is negative 0. Okay. So what that means, it's going to start with a very small negative number. So it makes sense that it's continued from that point. And as it approaches, I'm going to do that in black. That's going to be negative 0. So 1 divided by negative 0 is negative infinity. So at pi right there, it goes to negative infinity. And there is an asymptote. Okay, I'm going to do the asymptote in red. Okay, and that point right there is pi. And this pattern repeats. So from here to here and here to there, so it's at 0 to pi, or pi to 2 pi, it looks pretty much identical. So this shape is repeated. So I just need to draw another shape which is identical to this one. and there is the asymptote, and that's what 2 pi is, okay? 2 pi. All right, that's it.